Hi, in this video we're going to talk about how do we graph sine and cosine. We're going to develop parent functions, graph vertical dilations and horizontal dilations. Let's get to it. Another way that you can see these functions is just build a table going around the unit circle. Where sine, you would just put all the y values, from your coordinates, and cosine would of course be the x values of these coordinates. So go ahead and fill in these tables. As you can see, both of these tables go between 0 and -1. And if we were to plot these y values, at 0 we're at 0, pi over 2 we're at 1, and so forth, what we end up getting is a graph that's shaped like this. Now we can do the exact same thing for cosine. At 0 we're at 1, pi over 2 we're at 0, and so forth. And the parent function for cosine looks like this. And to get the basic shape and things like that, you'd actually need to graph all these intermediate values as well. But these are the basics for the parent functions of sine and cosine. And as you could see from the video earlier, these actually just continue on and on and on because these are waves. Hey, so at the beginning of this frame, I said another way to see these. It's because there was another thing, but it screwed up. So just know that to find sine, you're following the y coordinates around, and to find cosine, you're following the x coordinates around, or the distance from the y-axis. So now take a second just to pause the video and write down the basics of the parent functions. Some things to really note is that they both have infinite domains, but their ranges for the parents are stuck between -1 and 1. A sine function is odd because it has origin symmetry, and a cosine function is even because it has y-axis. And look at these transformations. Y equals a sine of bx plus c plus d. Same thing for cosine. This looks a whole lot like all of the other parent functions that we've played with before, and we're actually going to see how closely they're related. The very first thing that we're going to look at is this a, the amplitude, right? In all other functions, this is a stretch. It's pretty much the exact same thing for sine and cosine. It's half the distance between the max and the min points. So just think from this middle line, it's the distance to the top of the wave. So here we have y equals 3 sine x and y equals 1/4 cosine x. These are the only transformations that it's stretched by 3 or compressed by 1/4. So whenever I'm graphing this function, the only difference for sine is that instead of going up to 1, this is going to go all the way up to 3 and down to -3. Or for cosine, remember cosine starts at the top. Cosine will only go up to 1/4 and down to -1/4. If your graph is negative, you have a reflection over the x-axis. So as here, this is the cosine graph. The negative cosine would start at the bottom and go up. Sine still starts at the origin, but instead of going up first, it'll go down first if it's negative. Just because, you can see that these are reflections over the x. So let's try this. -2 sine x. The 2 tells me that's its amplitude. So I'm going to go up 2 and down 2. And since it's a reflection, sine starts at the origin, but it's going to go down first. And it's still going to hit all these key points at pi over 2, pi, 3 pi over 2, and 2 pi. And these, again, just come from the unit circle like we saw earlier in the video. Take a second and see if you can graph y equals -3 cosine x, and then compare it with mine. Cosine either starts at its max or min. Since it's negative, we start at the bottom and we went up first. And remember that this would just keep on repeating itself. Whenever I talk about continuing to repeat itself because it's a wave, we've only been graphing one cycle or one period. You see, this is a sine wave which would continue, but one period is just however long it takes to complete a cycle before it just starts repeating itself again. And the period can be found by taking 2 pi over b. And of course that b comes from the y equals a sine bx plus c plus d. We're talking about this b right here. So what's the period of y equals sine of x over 3? Well, this can be thought of as y equals sine of 1/3 x. So b is equal to 1/3. And that's going to tell me that the period is going to be 2 pi over 1/3, or 6 pi. So whereas the parent function only takes 2 pi to complete, this function would take 6 pi to graph one full cycle. You see, and here we have it. The sine of x over 3 to complete its full cycle took 6 pi to complete. But how do we find, these max and min points and where it hits the x-axis? To find those points, you just take the period, divide it by 4, and then successively add those points. So let's try this. Y equals cosine of 1/4 x. The period is 2 pi over b, which is 2 pi over 1/4, which is 8 pi. So I know that this is going to end after 8 pi. Now to find these key points, I'm going to take 8 pi and divide it by 4. So this would be every 2 pi, there's going to be a key point. So I'm going to say, starting at 0, I just keep adding 2 pi. 2 pi, 4 pi, 6 pi, and finally I end at 8 pi. And this should let me complete a full cycle. The 1/4 told me that I'm only going to go up to a fourth and down to negative 1/4. It's a positive cosine, so it starts at the top. 2 pi, 4 pi is negative 1/4, 6 pi back at 0, and 8 pi we're at a fourth. And that would be one cycle of the cosine of 1/4 x. So today we covered what this a and the b do to sine and cosine graphs. Remember, a is our amplitude, which gives us our vertical stretch, and b helps us find the period, which is 2 pi over b. So this is just like any other function where something multiplies the x. This is a horizontal stretch or compression. All right, we'll do more transformations later. Goodbye.